Hi, welcome to our poster section. This is Hao Dachu from User Understanding team in Microsoft. Today I'm going to present our recent work on large-scale resource-efficient models for task-oriented dialogue system with data augmentation and knowledge distillation. This is a joint work with my colleagues in Microsoft. Uh, so one of the biggest challenges facing in task-oriented dialogue system is the lack of labeled data to train these complex networks. This resource requirement is compounded in industry applications with hundreds of different domains and thousands of different skills. Even if we have enough resource at our disposal, it's still challenging to obtain manual annotations on this data due to some privacy concerns in practice. In contrast to manually annotated data, it is possible to use large amounts of unlabeled data. However, it remains a challenge problem for using this unlabeled data in large-scale neural models. And how much do we need more besides when does unlabeled data help and how much do we need still requires further investigation. Finally, the usage of deep neural models also increase the memory and the latency in runtime, posing some challenges to deploy these complex neural models in practice application. In this work, we develop a framework for deploying deep pre-trained language model for industry applications. Specifically, we develop augmentation strategies to using self-training and consistent learning for slot tagging to improve pre-training models in low-resource setting. Furthermore, we leverage knowledge distillation to compress these improved but huge neural models into shallow models that are deployable in practice application, achieving 21 times inference speed up while maintaining similar performance. Finally, we show that task-specific unlabeled data are key for achieving good performance in knowledge distillation. Our overall framework is illustrated in Figure 1. We start with a huge language model like BERT that is pre-trained on public wiki. We continue pre-training the language model on large-scale unlabeled user utterance from our dialogue system to make it aware of the domain semantics and vocabulary for task-oriented actions. We further fine-tune the language model on some amount of labeled data for task of interest. Given the limitation with small training data, we improve the language model with augmentation technology like consistent learning, leverage using back translation, and self-training to make use of large amounts of unlabeled data when available. Given the improved language model with augmentation technology, we further leverage knowledge distillation to compress this huge model into deployable one with lower latency and memory footprint. We perform experiments on real-world user utterance sampled from our in-house conversational AI system. In our experiment, we primarily focus on low-resource settings with small amount of labeled training data. Accordingly, most of the experiment results are reported on data from Table 1. In Table 2, we have shown the contribution of unlabeled data in language model. In Table 3, we conduct ablation study to understand the contribution of different data augmentation strategy. We also summarize our distillation result on Table 5, demonstrating the effectiveness of unlabeled data in knowledge distillation. For more details, please join our poster section. Thanks for your attention.